Okay. Can you hear me? Perfect. Yeah, welcome to my session. Welcome to the jungle, a safari through the JVM landscape. I had a really fancy slide set, really nice one, but I had to ditch it because I have to use the corporate one. So sorry for the boring slides. And I have to warn you, this is lots of facts. No fancy coding, no fancy news. Probably most of you, because I see gray hair here, you know all of that. But anyway, so just to warn you. So my name is Gerrit Grunwald. I'm working for Azul as a developer advocate, doing Java for some time and also other stuff, but that's not important here. We start directly, OpenJDK. If people talk about OpenJDK, they usually talk about Oracle OpenJDK. So because OpenJDK is just the software itself, it's not really a product or something. It's the code and you can build it, right? This is OpenJDK. It's a free and open source implementation of the Java Platform Standard Edition called Java SE. That's what it is. And you can find it on GitHub since JDK 16. Before it was on Mercurial. So you can look into the code, you can become a committer, which is not easy, but you can. And that leads me directly to the contributors, because you might think this is maybe only done by Oracle. Well, it's not. It's done by all of these companies. There you see in the middle, there's independent. That means it's independent committers, like people like you and me. They also contribute to the OpenJDK project. And you see big names like Amazon, IBM, Intel, and others, Microsoft, and I don't know. So it's interesting, and it should give you a good feeling to see that so many big companies providing code to OpenJDK, because that makes it safe and stable and long-lasting, hopefully. So it's not a one-man show, okay? And you can participate if you like. And some basics first. So we have the JDK, we have the JRE, which means it's the Java Development Kit and the Java Runtime Environment. And then what it is the JRE, the Java Runtime Environment, it encapsulates and contains the Java virtual machine to run code and the class libraries. And then we have the JDK, which is a superset of that. And it also comes with a Java C compiler, debugger, Javadoc, and other stuff that I don't mention here. So that means the recommendation to JDK 8 is if you run in development, you usually use a JDK. If you run in production, you usually use a JRE. This is different from JDK 9 onwards. But, and people might ask, why should I use a JRE in production? Because it's smaller. And if you run a microservice environment, you would like to keep it as small as possible. You don't need the Java C compiler and all these things that you need for development. So that's the reason you usually use the JRE in production. If we look about something past JDK 8, you just create your own JDK modules that you need using JLink. So can I ask who's using JLink here? I don't see any hand. So you should, who's running Java 8? Okay, and everything above Java 8. So you should use JLink. Just take a look at it, it's worth it. You can create really smaller JDKs that you can use in production. Okay, just for those of you that's not really aware of the roadmap, if we take a look at the old release cadence of the OpenJDK, then I start here with version 6 because before that it's too old. Then you see from version 6 to 7, it took 4.5 years. That was a long time waiting for something new. And from 7 to 8, another 3 years. And then they changed the release cadence to something faster. So because that meant you have to wait years before you can take a look at new stuff, right? Because it was simply not available. You heard about something, and then they released it, and then you can start playing around with it, and it takes another half a year or year to really get it into production. And then they changed it to this, which is the new release cadence. And you see we have versions like 9, 10, 11, 12, and so on. And it's really a lot of versions coming out these days. And then we have these pink ones, and these are the so-called long-term support versions. Before that, we didn't have really this definition, but now we have. And between 11 and 17, we got 3 years. And now, from 17 onwards, we have 2 years between long-term support versions, which is great. And then you have all these different versions in between that you can use for testing. Means now you can test new features every 6 months, which is great. Okay, that's the timeline. Support. I already mentioned LTS, and there's also STS, which is short-term support versions. That have been the ones without the pink color. They come out every 6 months, like 16, like 18, 19, stuff like that. And then there's this LTS stuff, which is the long-term support, which could be years, right? Like from now till 2029, something like that. So this is all the versions from version 9. And then you see the time at the bottom. And all the white ones are STS releases. And you see this, they are now arrows. And I come to that in a second. The pink ones are the long-term support versions. And you see long-term means really long-term, right? So JDK 11 extended support ends in 2026. And for 17, it's September 2029. So that means you can expect security updates up to this point. Sometimes Oracle extends that even longer. But what's with the other ones in between, right? Why should I use an LTS over an STS version, right? The problem is short-term support versions only have support for 6 months until the next one will come out. So if you jump on, let's say, 15, and then 6 months later you get 16, you won't get any security updates for 15 anymore. So if something happens in 16 that affects 15, your problem. You have to jump to the next version. And this is something you have to keep in mind because you don't want to do that in production, right? So the recommendation is, of course, you can use STS and LTS in development, but in production, please only use LTS versions to make sure this is the stable version where you get security updates for a long time, right? That's important to know. And this is maybe now the most fancy part, distributions, because this is the question why I created this session. And people approached us and asked us, yeah, there are all these different versions, so what's the difference? And I created an API for FooJ, the Disco API, talked about it last year, and then I stumbled upon all these different distributions, which are builds of OpenJDK first. And this is the list. This is a lot, right? This is all builds of OpenJDK. You will, adapt OpenJDK is dead, right? Probably you know that. Someone running still on adapt OpenJDK here? Probably not, that's good. We have Bsheng. Someone ever heard of that? Or Tencent Kona, right? Stuff like this. It's widely used, not maybe here in Europe, but in China and Asia. And it's 20 different distributions. They are all based on OpenJDK. And I told you OpenJDK is just the software. So that means you can take the code and build it on your own, and then you have your own JDK, and you are ready to go. As long as you use it for your own stuff, fine, do it, right? Then there are builds of GraalVM. So who's using GraalVM here? In production. That's the important part. A few, okay. And even there we have, in the meantime, not only one, but we have Glue on GraalVM, we have the community and the enterprise edition from Oracle, we have Liberica Native Image Kit, and we have Mandrel, which is the one from Red Hat. So again, there's code available that you can build, and then you can make your own product out of it. But it's all the same, right? And it's not really a big difference here, except between the community and enterprise edition of Oracle, because the enterprise you have to pay for, and it contains stuff that is not available for the others. So that means except the enterprise edition, all the others are the same, more or less. Again, except because the Liberica stuff comes with some neat features. We come to that later. So that means those who have the choice are spoiled for the choice. So it's up to you what you would like to use. But of course, there are some points you have to keep in mind. First of all, the stuff that you find here is all the same. That means if you run your Java application on it, it will run, no problem. But there are other things that are important to know. So first of all, there is the point updates, right? So we have the CPU update, critical patch update, and then there is the PSU update, which is the patch set update, right? And the CPU update, it just fixes vulnerabilities and critical bugs. And that's it. Where the PSU contains the CPU, plus it also fixes non-critical issues, and it can introduce new features, right? And this is important, because we will come to that. If you introduce new features, it can introduce new issues, right? This is the way it is. Of course, you can argue that also the other fixed issues can introduce new stuff. That's true, but the probability is higher if you introduce completely new stuff that there might be a vulnerability or something else in there. So how it works is 4 times a year, there will be this with the new release cadence. We will see this, for example, 1701 in January. And you see on top the PSU that contains the CPU. And in the bottom, you just see the CPU. So in April, we get the 1702. And what happens is that the 1702, from the critical patch updates, it contains everything from the PSU from 1701, right? Just the critical fixes. That means every time you install a CPU, you are 1 version behind related to new features and stuff. That might be a problem for some people. But to be honest, if you run something in production, you would like to make it as secure as possible. So the reason for that is that then you should use a CPU release, always. So and that's happening in July and also in October. That's how it works, right? So you might wonder that I never saw a CPU, right? Who's using a CPU update here? 1, I see. The problem is that it's not really mentioned anywhere, except on the, you might remember, if you download JDK 8 from the Oracle website, they had something like 80252, 80253. And that was the PSU and CPU. That was the difference. But to be honest, when I saw it at that time, I had no idea what it is. I thought, oh, whatever, I just don't download one of them. But if you run stuff in production, you should make sure that it's using the CPU, if it's mission critical. Now the question is, who is really providing the CPU updates? So patch set updates, PSU, this is mainly the stuff that you can get from everyone. If you download Corrado and you get the new update, it's a PSU. If you download Tamarin, it's a PSU. So the only ones that really provide CPU updates is Azul, Bellsoft, and Oracle. Everybody else doesn't do that. So, and these things are not available on the website because probably you have to pay for that, right? It's bound to a support contract most of the times, which makes sense. So that means recommended is in development, whatever you like. In production, if it's mission critical, you should really use something that has a CPU update, not the PSU. This could be important. It really depends on the kind of stuff you're doing, but this is the recommendation that we have. Compliance, that's another one where you can distinguish between distributions, because that's the stuff that might be your problem. I have so many distributions, which one should I use? What's the difference? We saw the updates, that's the difference. Some have more secure, or let's say not more secure, but it's updates that are better for production, where we have others that just are totally fine, but they introduce new stuff every time. Compliance is another thing. There's something called the TCK. Who heard about the TCK? Who know what the TCK is? Okay, a few, that's good, because it's not that easy. It's the so-called Technology Compatibility Kit, and it's licensed by Oracle. And what it is, it was originally developed by Sun Microsystems. It's now intellectual property of Oracle. And just to give you an example, for Java 11, you need to run 120,000 tests to be compliant to the TCK. And any binary that you produce have to pass the test. So that means you create one on Windows 64. For Intel, you have to run the tests to be sure it's okay. Then you can deploy it. If you run it on Windows ARM, again, you have to test the package. It's a lot of testing that's involved here. And this is not really the TCK that you use for testing, but it's the JCK, which is the Java Compatibility Kit, which is part of the TCK, right? And this tests features that, for example, are likely to differ on different platforms, right? So you have, for example, you have a Mac that is running on Intel, and you have a Mac running on ARM. So you have to make sure that it works the same on both platforms, right? So you have to run the test on this one and on this one to make sure everything's right. So this is the hardware operating system specific behavior, which could be different. Sometimes it's things that have to be ported to different platforms that have to be tested if it works. They mask specific hardware behavior. For example, it will be part of the test is testing the sound card. That's interesting, right? So you don't have a sound card on your server, have you? But it's part of the test. So it's lots of tests involved in the JCK to really make sure, and this is all written in Java. It's code from the OpenJDK that's used to test it. And it's very interesting to see. You can get the JCK, you can get it, and you can run the tests on your machine, but just be prepared, it takes forever. And that might give you an idea why it is a good idea to use a TCK-tested distribution, because once it passes all these tests in the JCK, you can make sure it works reliable. And then you can exchange distributions that pass the JCK, because it was made sure by the vendor that it passes all the tests, means your application will probably run without any problem. Where when you build it on your machine, you can't really prove it. Right? So you can use it on your own, but that's it. So how to get the JCK, how to access it. So it's available at no charge, usually, and you must meet the terms of the OCTLA, which is the OpenJDK Community TCK License Agreement, right? Nice word, and yeah, a good read if you have a lot of time. And you must also sign the OCA, which is the Oracle Contributor Agreement. If you do that, you can make sure that your distribution is compliant to the TCK by running the JCK tests, okay? So here are some distributions that pass that are compliant to the JDK 8. And this is again a difference, because just because one vendor says, oh, we are TCK compliant, well, that's fine. It doesn't say, we are just do it for JDK 8. But we also have JDK 11, but for that one, we are not TCK compliant. So you might want to check that, because it's easy to put it on the website, we are TCK compliant, but you don't really know. So there are some vendors like us, we provide for each package that you download, we provide a PDF that says it passes the test. It doesn't mean anything, right? But at least you have something where you can come to us and say, you said you passed it with this specific package, now you have to prove it. But others just put it on the website, so you have to be aware of that. So in this case, for example, Bisheng passed it for JDK 8, but if we take a look at the JDK 9 and above, Bisheng doesn't pass it there. So if you download the Bisheng distribution for 11, it's not TCK compliant, because they did something to the code in the code base that is not TCK compliant. So that means it can break your application. So you have to be aware of that. Okay, but you see a lot of the usual suspects here passing the TCK for JDK 11 and above. Shouldn't be a problem. So in short, it's a suite of tools to allow verification that you conform to the JSR, Java Specification Request. Okay, and that's what the TCK is. Then we have Eclipse Aquavit. Who knows that? Some? Yeah, it's quite new. It's the Adoptium Quality Assurance, Vitality, and Speed Test Suite. These names are really terrible. It's by Eclipse, and it came with the Adoptium project, and they figured out it might be a good idea to have another test suite that is huge and make sure that it's that you are compliant to that one. And this is a different, it's at a different angle a little bit. This is more related to application performance and these kind of things. So it ensures that all additional qualities are present, make it suitable for production use, and so on and so on. So I don't want to read to all these things. You can read it on your own faster than I can read it here. It's again a lot of tests, and it's available, but therefore you have to also fulfill some things with Eclipse. These are the distributions that have or that are compliant to the Aquavit test suite. You can find them also on the Adoptium marketplace. So this is the website. Who knows Adoptium? Okay. And there is a place that's Adoptium marketplace, and all the distributions on that marketplace have to be compliant to the TCK and the Aquavit test suites. So if you want to make sure you get let's say, a good tested distribution, you want to look there. Okay. Recommendation, whatever you like to use in development, just do it. In production, I would make sure that it's TCK compliant, to be honest. And sometimes it's even, or most of the times I heard, it's even required. So you can't just choose anything you want. It has to be compliant to TCK. Okay, this might be something interesting because also people approached us and asked, okay, we have all this distribution, which is the fastest? Well, if we take a look at the baseline performance and it's all OpenJDK, it's all the same speed. It's really not, you can make some tests, but you won't really see a huge difference between these distributions here. There are some differences, but I will come to that in a second. But you see, most of the distributions have the same performance. So performance is really not an argument using Corretto or Dragonwell. If it's both OpenJDK based, not a big deal. So more or less the same, with some exceptions. And to get to the exceptions, I have to shortly dig into the JVM. So we have 3 different modules here. The class loader subsystem, the JVM memory, the execution engine. Why I mention this is you can change stuff in the JDK to make it faster, right? But therefore, we have to take a short look what it contains. So class loader subsystem, we have the loading, the bootstrap class loader, extension and application class loaders, we have linking and initialization and so on. We don't want to go into that. Then we have JVM memory with the method area, the heap, stack, PC register, and so on. We can't do any performance improvements there. But there's the execution engine, and it contains the interpreter, the compilers, the C1 and C2 compiler, and the profiler, the garbage collectors, and also native method interface, and so on, native method libraries. And if we take a closer look, then we can, at these 2 points, we can do some improvements, because we can replace that. And for example, we can put in a different compiler, or we can tune the garbage collector by another one, which could lead to improvements in performance. So these 3 versions, this is my personal opinion, and I checked that with other ones, so I could recommend for high performance applications. So that means if you need more than the OpenJDK can offer you, you might want to take a look at the Azul Platform Prime, IBM Samaru, or at the Oracle GraalVM Enterprise Edition. So, and then I talk about the native image stuff for Graal Enterprise. So what we did, we just exchanged the compiler with our own compiler and also the garbage collector with our own garbage collector, which both are better than the stuff that is available in OpenJDK. IBM Samaru is based on OpenJ9, which is their own JVM, which is also faster and has a better startup. And Oracle GraalVM is a totally different beast, and I have also some slides about that. We come to that in a second. But these are the 3 that I would recommend if you would really need to build high-performance applications, then you should take a look at these ones. Cost, oh yeah, that's a nice one, because this stuff is all for free. You can use it, no problem. And then you might wonder, okay, there are other stuff. Yes, there's also stuff you have to pay for. There's Platform Prime, Platform Core that we offer, and there's IBM Samaru, the certified version, you have to pay for that, GraalVM Enterprise, and Oracle JDK. I have to ask, who's using Oracle JDK here? Don't be shy. Nobody? I can't believe it. Oh, 1. Okay. This is core-based license, and this is really simplified. But last week, maybe you heard of it, Oracle changed the licensing to a very interesting approach. It makes it so much easier for them, because instead of counting you on vCores or something, they just said, oh, you know what, your company has 1,000 employees, you pay for 1,000 employees. We don't care how often you use it. And that might get very expensive for some companies. Just be aware of that. And now I have to do a shameless plug, because we offer the same by a third of the price. So if you're running into problems with licensing, pricing, just come to our booth and we can help you there. Now we come to some special things. Who's using JavaFX here? I always have to ask that question. 1, okay, 2, 3, a few. It was never really part of the JDK officially. So it came bundled for some time from Oracle, and then they dropped it. And so now if you would like to use a bundled version, it's available by Azul, by Bell Software Liberica, and this is the interesting part. the Bells of Liberica NIC, which is the native image kit, is the GraalVM version. It comes bundled with JavaFX. So keep that in mind, because it's the only one they do that. If you're looking for bundled stuff, then this is the stuff you have to look for. ARM32, is someone using ARM32 here? Embedded? Nobody? Yeah, this is usually the case at developer conferences, but we have customers and they are not small. They run on embedded. And it's only Zulu from Azul and Bells of Liberica, they provide ARM32 builds, as far as I could find. So I might be wrong, but just to let you know. Then we come to some alternatives. So now we saw all this OpenJDK thing. That's nice. And also mention that there are some things that are better than others. Or they have different approaches, like Amazon Corrado. And since I think it was January or December, I'm not sure, they came up with SnapStart, right? Which is a faster startup by using Crack and Firecracker. But that's what they do to improve the startup time, mainly for Lambdas. Who's using Lambdas here? Okay, a few. Yeah, great. So give it a try. I mean, we introduced Crack to OpenJDK, and then they took it and built it into Corrado. Nice move. Unfortunately, we are not that fast. Then there's Alibaba Dragonwell. Not that well known in the Western world, but in Asia it's big. And they have some things in there. They have 2 different editions, standard and extended. They have JWarmup, which I have to be honest, it's a copy of the stuff that we invented before we just separated it completely from the OpenJDK, and they took that stuff. It's experimental. It works kind of. They have the Elastic Heap. It's a garbage collection feature to give back memory. And they have so-called WISP2, which is a stack-full symmetric coroutine that's at the JVM level. They implemented that. So never tried that, but they have some charts on their website. So that makes it a little bit special. They have different things, and they say it's optimized for their cloud, probably. Then there's Tencent Kona, which probably nobody ever heard of. It's specialized on ARM, with mainly embedded. What they did, it's quite interesting. They have, and I can't say if it's a port of Loom or if it's their own development, but they have so-called Kona fibers, which is more or less Loom, and it's compatible to Loom in JDK 8 and 11 on ARM. And they have big improvements, and they even claim it's faster than Loom in JDK 19. So, and they have ZGC garbage collection for ARM, which also, so it's for them it's great, because they are specialized on embedded. So if you're embedded, you should take a look at Tencent Kona. But just be aware, the website's all in Chinese. So use Google Translate or something. Otherwise, no chance. Then there's Oracle GraalVM. We had that already. It is Community and Enterprise Edition. We have a polyglot VM. It can run Java, JavaScript, Python, Ruby, R. It has a GraalJIT compiler, which is a replacement for the C2 compiler. And it's written in Java. And then they create a native image out of it, and they eat their own dog food, right? That's the idea. It's better to maintain than the C2. And they have the Graal AOT compiler. And this is used for the native image stuff, the ahead of time compilation, which makes it special and standing out of the other stuff. IBM Semaru. Who's using IBM Semaru here? Someone? Not? It seems to be good. I've never tried it too. So it comes with the OpenJ9 JVM, which is completely done by IBM. It has a faster startup. It has lower memory footprint. It also comes with an AOT compiler. It was a little bit confusing to me because it says it's dynamically compiled AOT code. How can you dynamically compile ahead of time compilation? So, okay, we will clear that up, but this is, that's what it says. It has instant on, which is in principle exactly the same that Crack is, just for OpenJ9. And it has a JIT server, which is a decoupled remote JIT compiler. Right? You can also get that. Then we have Zulu from Azul, of course. It comes with something new, which is called Azul Vulnerability Detection. And you probably know all the stuff from Sneak and JFrog and these kind of things that scan your code for vulnerabilities before you run it in production. This is a new approach because what we do, because we own the JVM, and the JVM compiles the code. Every time you load classes, we can ask a web service to, is this class vulnerable or not? Or is it part of a library that's vulnerable or not? We can even detect if it's loaded or not. So it means you can use log4j as a dependency, but you never use it, then it's fine, right? And we can tell you that. That's the vulnerability detection. And we have crack as an experimental feature right now, so it will probably end up in our JVMs, but not at the moment. It's just you can download an experimental version of it and play around with it. And then we have also Platform Prime. I also already mentioned that. This had a lot of stuff, which is we have our own JIT compiler replacing the C2 compiler in OpenJDK. We have our own garbage collection, which is pauseless, and we can do heaps up to 20 terabytes with pauseless garbage collection. And we have Ready Now, which is too much to explain it in a session now. And Cloud Native Compiler, which is a decoupled compiler that's running in the cloud and do the optimizations for you. And then it also comes with the vulnerability detection in the JVM. So this is another specific version. So now I have some recommendations that I came up with that might help you, but I might be wrong. If you start a new project and you use some frameworks like Spring Boot, Jfokus, or Micronaut, then you probably can use any build of OpenJDK. It doesn't really matter. Make sure it's TCK compliant, and if possible, it should have CPU support, right? If it's mission critical, to make sure you have really just the fixes for the vulnerabilities and not all the new stuff. If you build microservices and there's no demand for fast startup, or no matter of lifespan and resources, then again, you can just use any build of OpenJDK, and it should be TCK compliant, of course, right? So no matter, that doesn't really make a big difference. If you have microservices that are short-lived, minimal resources are needed, and you have a demand for fast startup, you can use either Zulu with crack, you can use Amazon Corretto with Snapstart, Graal native image, makes sense. Just be aware that if you use Graal native image and you use just the community edition, you don't get all this stuff that is available, like the PGO, the profile guided optimization and stuff. This is only available in the enterprise edition. And you can use IBM Summer with Instant On, which is in principle the same as crack and Snapstart, just on OpenJ9. This really helps you to reduce the startup time to a minimum. If you build microservices and you have really huge resources and a demand for fast startup, you might want to use Platform Prime because we have stuff to make that faster, Zulu with crack, and again, Corretto with Snapstart, IBM Summer with Instant On. That helps you there. GraalVM native image is not that nice. If you have a lot of dependencies and if you have reflection, these are the weak points. So that's the reason why I don't put it here for this kind of stuff. If you just create services with a demand of high performance, Platform Prime or IBM Summer certified might be the ones you want to take a look at, right? If you have services with demand for high performance and normal heap size, so normal heap size doesn't mean in the terabytes, right? Platform Prime or any build of OpenJDK with the support for Shenandoah or ZGC might be good, right? Because then high performance in this case means low latency, so we don't want to have garbage collection pauses here. And if you really have large heap sizes and you create whatever service and you need low latency, then Azul Platform Prime is the only really thing that can handle that. At this time, it might change in the future. ZGC is getting there, but still at the moment, Azul Platform Prime can handle these large heaps the best. If you create a JavaFX desktop application, you have different choices. You can use Azul Zulu bundled with JavaFX, Bells of Liberica bundled with JavaFX, or you can use any build of OpenJDK, and you have to install JavaFX on your own. Right, so people ask that, so that's the reason why it's on here. I know just 2 people here use JavaFX or 3, but anyway, I put it on the list. If you create a native desktop application with JavaFX, which is possible, you either can use Bells of Liberica native image kit. It comes bundled with JavaFX, so you can create a native executable directly, or use Gluon GraalVM. Is someone using Gluon here? Nobody? Okay. If you would like to create a native mobile application, and yes, that's still possible with Java and JavaFX, then there's only Gluon GraalVM that can do that. Okay, and if you would like to know more, just come to our booth. JavaFX on ARM. This is very rare, but still there is a market for embedded, and that's only Zulu from Azul and Bells of Liberica that offers this, bundled with JavaFX and for the platform. Now, this is an interesting one. Who's running stuff on AWS? Okay, and then I guess everybody's using Corrado, right? Okay, makes sense. But I have some example for you. Because you can also run any other build of OpenJDK. But why would you do that? Well, maybe you get better support. Let me give you an example. Who's using Netflix? Nobody, come on. So I just counted everyone, yeah? They use Amazon, AWS, but they use Zulu from Azul because they said the service and support is better. So you can use that if you like. There's no way not to do it. Someone using Kafka or Cassandra here? Yeah? You probably would like to take a look at Azure Platform Prime. We really, and I just have to tell this because it was a little bit surprising to me too. When we run it with Kafka, you can expect up to 30 to 50% of performance increase just by using another JVM, and you don't have to change the code. So, and you can, it's a free version for download and testing. If you go to production, you have to talk to us. But for testing it, give it a try. It's faster. Don't ask me why. I just know it's faster. So the takeaway, and I hope, because I never gave the session before, so we have time, is there a real difference between all those plain builds of OpenJDK? Technically, no, it's the same. So whatever you use, it's up to you, your decision. If it comes to service support and cost, probably yes. So think about it. It's really the thing. If you're a startup, you don't have a lot of money, you say, I just take whatever, OpenJDK build and run it. At some point, you might run into problems needing support, needing service, and then it might get into problems. So the idea is choose wisely when you select a JDK. That's what I have to say. And now, I'm up for questions. I think we still have now 8 minutes. And you have to really scream at me because I heard it's hard to understand. So any questions related to JDKs and distributions? Oh, yeah. Ah, Vinny. Okay, so the question was, for JavaFX, which distributions are paid and which ones are free? They are all free. So you can, whatever you like. It's Liberica and Zulu, because JavaFX is also free. So you can just use that. Yep. Any other question? If no other question, then you are free. I gave you back 7 minutes. Enjoy the rest of the conference. Thanks for attending.